Hello everyone. In this video we are going to learn about call and apply methods in JavaScript. So the call method is used to call a function with a provided this value and arguments. So let's say this is a function and it has some arguments and it has, so let's say some function foo is there and it has some argument, let's say n, and it also has some uh, uses of this. So let's say this dot val plus n or something like this is there. Okay, so the idea is that this is also used and some argument is also used. Now you can understand that you can use the method call on this foo. So it is similar to bind, but the difference is that bind the bind used to return another function which has the this value bound to it, right? In this case it directly calls the function. It directly calls the function and the result is returned as if you have called directly that function. So in this way you could understand that, let's say this thing is not there, and just for the sake of it I am saying that let's say there is some foo and you are calling it with 5, right? Now let's see, let's log it here. So let's log n here. Okay, so when we run this function, then we see that n is 5 as expected, right? And what is the value of this? So let's print the value of this, and when we call, then we see that this is basically global. So 5 and this you can see that this is global. So the value of n and value of this is there, somehow we call it. Next, earlier we saw that we could have, rather than calling it directly, we could have bound this function. So let's say foo dot bind, and we can bind whatever the arguments we need, whatever this we need. So let's say I need some this like val 20. This is the this I want, and argument also I want to bind, let's say 5. Okay, and now this will return me a new bound function. And then if I call foo directly without arguments also, then also it will work the same way. The only difference is that now this is not global, this is the value which I have bounded. Okay, so this thing is going to be val 20, and the argument is going to be 5 or whatever you have passed it here, right, while binding. Now actually call, you can understand, is like a shortcut for these two steps. So rather than doing this, actually you can, rather than doing this, you could directly call something, do something like foo dot call. So I am calling with a particular this, so let's say that is val 20, and some argument, let's say 5. So you see what is happening, that in this case we firstly bound the thing and then called it. Here when we do foo.call and provide a custom this and arguments, then actually it directly calls this function, as you can see, with this as the first argument and whatever the arguments you have passed as the second argument. So so why would we ever want to do that? We could have directly called it something like this also, right? The only main reason is that we could customize this, right? In this case we don't have control over this, right? It's like just that whatever the rules of global calling execution, and if we call something like obj dot foo, then this will be foo, this will be obj inside foo, all those things will be there. But apart from that we don't have more control. Here we have more control, that whatever we want, that we can pass as this, and when this is called, this function is called, then this will be bound to that thing. Okay, so now you understand the purpose of call. So in this case we can see that if my this is val 10, this object, and 5 is just one of the arguments, and we just need one argument, so only one argument is needed. From the second arguments one, whatever the things are passed, they will be passed to the function. The first one is this. So this dot val will be 10, here it will be 5. So 10 into 5, 50 is the answer when you, and directly it returns the answer, right? So you can directly see that this thing is printing, that is fine, but actually if you return this and you let's say print this value, whatever is returned, then you will see that directly this value is printed, like 20 plus 5 in this case, or 5 in this case, 10 into 5, 50. So directly it is as good as calling directly, right? It's not just binding, it's calling also. Okay, next let's take an example of this case. Let's say sum is there and a plus b. The only difference with respect to the earlier one is that now we are having two arguments, right? Earlier also we did the same thing, but this time rather than just having a single argument, this time we are having two arguments. So let's take this example. So this sum function is there and it has a, b, and just we are returning the sum, nothing else, right? Now the same thing what we did earlier we could do here also. So if we call sum with let's say 5 or 10, right? So obviously this will give us the answer whatever is needed, that is fine, 15. But the idea is that you could have also done, instead of 5, 10 passing like this, you could have done sum dot call, and now this is like we don't need this here. So but let's say we are trying, we have to call something here, right? You can write undefined or you can write null here as one of the arguments, and then from the second argument onwards the parameters, it is attached to the parameters. So the second and third argument will be the first and second argument of the called function. Okay, the first one will be this. So now we passing null has some nuance which we will discuss just next. But for now, since we are not using this at all, so whatever we are passing here, that doesn't matter right now. Okay, but 5 will be a and 10 will be b, and then the answer will be 15, right? So what is the point of doing this? Like we could have directly called sum of 5, 10, right? There's no point. It's just that I'm trying to show you that you could also use call to call in the similar manner, and even if you don't need this, then also you can call something like this, and this time you have to pass something here even if you don't need it. So let's say you can pass null. Okay, you'll see in more detail in a few minutes. Okay, so this is done. Now this is call. A similar function available, similar method available in JavaScript is called apply. Now apply is similar to call. The difference is that it also attaches a provided this value, but apart from that, the arguments which are provided for calling the function are not multiple arguments. It is actually a single argument which is an array of arguments which have to be passed. Okay, so by example it will be more clear. So let's say this thing is there, right? Some maybe this function, when this function was called, right? For clarity you can see that, let's say this thing is called, then you can see that the arguments are called like if you want 3 arguments and 3 arguments, 4 arguments, it will be like this, right? But in case of apply, these arguments are applied as an supplied as a array rather than just too many arguments, right? So you can see that in case of apply, if you use instead of call, if you use apply, then it will be everything, all the arguments will be in an array. So if we want to in this case we want to pass just 2 arguments, so that 5 and 10 will be in an array. Okay, and it will work exactly the same way like call did, just that whenever you convert call to apply, then you need to supply array rather than array of arguments rather than all the arguments as spread. Okay, and again you can understand that, let's say my args are in some variable. So let's say const args is equal to this array. Okay, then now you can clearly understand that you could do something like this also. This will also work, right? Or you could do something like this also, call, and now I need to spread this. You understand why? When you are having an array but you are using call, then it has to be spread, and that's why spread operator is used. This is exactly equivalent to the earlier one, right? And this is also 15. Okay, so both the syntaxes will work like this, and apart from that, call and apply are identical. The only difference is this thing. Okay, And the same thing is that, let's say, earlier we saw that we bound some this, and one argument 5 was passed, but since now we are using apply instead of call, so that one argument also should be inside an array. Okay, and that's why this 5 is an is like an array. Okay, but the answer will be here also same, 10 into 5, 50. Okay, so let's go to call in slightly more detail. Let's see, we have a function foo, and this dot val we are returning. Now if we call like this, then val10 is what? Val10 is, so just give me a moment. So obviously, since we are using call, the first argument will be used as this inside when you are calling this function. Then this is going to be val10, and this dot val is going to be 10, and that's why that is going to be returned. Just we all earlier discussed this, but let's repeat it. Foo dot bind. If we could do the same thing using bind, then we would do something like this: that we will bind this firstly, let's say, and since there are no arguments, then this is sufficient, right? Foo dot bind. This thing is bound, and then if you call simply foo, the new bound function, then that will return you whatever the this dot val is there. Okay, so that will be 5 in this case. And you can also try doing something like this, that foo dot bind val 5, and then again do, instead of directly calling foo, you can again do foo dot call and again pass it this. But like bind, if you can call it multiple times, but only it can be only bound once, which means that the second bind, third bind, all that will be redundant, that will not be used, only the first bind will be used. Similarly, in this case, you can understand that the first bind will be used. If you call it with some another this, that will be ignored. That will be sort of a second bind. The first bind, whatever is there, and that's why if you call something like this, then it will be this will be ignored, and still this dot val inside when you are calling this function will be still the earlier bound value. The earlier bound value of this is val 5, and that's why this dot val will be 5 only. Next, let's see multiple arguments a, b, and let's say we are using this also, this dot val. Now if we use something like this, then what will happen? This is val 5, so this dot val will be 5, a and b will be 20 and 30 respectively. So if when you call, then 5, 20, 30 will be printed. That is fine. Again, the earlier things, like we know that bind, you don't need to bind all the arguments, right? You can bind partial list of a subset of arguments also you can bind, but that will be like starting from the left. Okay, so let's say instead of 2 arguments, you are just binding 1 argument, then starting from left, 1 argument will be bound, which means that a will be bound to 20 and b is still not bound. When you are calling that function, then your whatever the arguments you are calling, that will be the first one will be the second argument in this case, right? Because a is already bound. So now what will be printed? If this dot val is 5, a is 20, b is 30, so 5, 20, 30 same. Okay, let's consider this scenario. Now if you call something like this, that foo dot bind and val 520, and now if you call null 30, which means that obviously I'm passing null, because even if you pass some object, that will be ignored, right? We know that already the binding of this has happened, so this will be ignored. So anyways, let's pass the null or something, because we are interested in using call. And if you are using call, then we have to pass the arguments from the second argument onwards, right? So this 30 will be the first argument to foo, right? The first argument to foo, like this here, this can be replaced like this. Now if you do something like this, then foo has already a bound argument 20. So again, if you are calling like this, then even if you are calling this using call also, then the behavior will be similar to here. So this is going to be actually the second argument. This is going to be b, because a is already bound to 20. And here also you will see that you will get the print on the console 5, 20, 30. Let's see this scenario. Now we are interested in the value of this. So if if the code is the function is being executed in a non-strict mode, then we know that if we are calling a function, so let's say this function we are calling, right? And we know that even if we use earlier we saw that if we bind, let's say if you bind null, if we bind this to null, then in non-strict mode we used to get global or window object, right, depending on the environment. Similarly, that will happen here also. And the second thing, in strict mode, the behavior was what? The behavior was that we used to get undefined if we directly call from global context, but without binding this, right? But in call, there is no way to avoid binding this. You have to pass some argument, the first one, right? So obviously that undefined thing will not happen. What will actually happen, that in a strict mode, yeah, this should be undefined, but actually just if you're directly calling. But you remember that this is equivalent to firstly binding it to null. Now you remember that in a strict mode, if you bound to null, then you got null as this, and that's why that will be the behavior here. If you directly call with null in strict mode, then this is going to be null in accordance with that earlier thing, right? So if you remember, just let me clarify that. So this sum, let's say this sum function is there, yeah, so that is fine. And yeah, so let's simply see this this value. So console log this, okay. And I am saying that, let's say when we are directly calling sum, let's say 510, right, then obviously 15 will be returned, but the idea is that this will be global. This will be global because it is in it is in like just global context, it is called, right? But that is not the point. The main point was that what if we did something like sum is equal to sum dot bind null, okay, null. Now we remember that if we do something like this, this will be still global. And not only this, had this sum be like something like obj dot sum somewhere, right, then also if you do something like this, then this will be global rather than obj, that we saw earlier in the case of learning bind, right? Same thing will happen here. So that's what the example. Now we saw that if we use strict, which means that if we are in strict mode, then if we are directly calling, this is what I was referring to earlier. If we are directly calling, then it is undefined. But you remember that if we bind it to null, then this thing is null rather than undefined, right? And when we are doing something like sum dot call null and let's say 510, then you can understand that this thing is equivalent to these two lines, right? And that's why, since this is use strict, this thing, this variable is going to be null, right? And that's why it is null. And obviously the return value will be 15, that is fine, you can print it out. But the main point is this will be null. Had this not been strict mode, then this would have been global as expected. So yeah, that is what it is here. Next, yeah, so let's say there is a this, and whatever this we are passing, that is val 10, and 2 3 we are passing, right? Then a plus b is greater than 5, right? Now let's see the same thing as a arrow function. Now you see that in this case, whatever this you are passing, that thing is going to val 10. Whatever this you are passing, that thing is going to here inside the function, that this thing is bound. But we know that in arrow function this cannot be bound, right? So even if you pass something like this, actually this is whatever is outside this function, whatever is this, right? Outside this arrow function. Outside this arrow function, what is this? In Node.js environment, there will be empty object, and in browser environment, that can be a window, right? So even if you try to do something like this will be completely ignored, because this sum is not a normal function, it is an arrow function, okay? So the answer will be still 5, but if you try to print this and use value of this in some way, then just pay attention that is going to be this thing, whatever the default behavior is there, empty object or window, rather than what you are passing. That is not the thing which is going to be bound, because this is an arrow function. Next, when we are attaching this, then it's not that this must be some object always, right? In fact, you can pass some primitive value also, but that will be converted to object, okay? So we see that if this function is there, and if we are passing yeah, anything, val 34, whatever. So we can see that this is going to be val 34, but you can pass like any value, right? Let's say you pass 30, right? So now this will be bound to 30, but that 30 is an object 30 rather than like the directly primitive 30. So you understand, this thing is exactly same as this thing. So actually internally it is converted to new number 30, something like this, you can understand. Okay, and and apart from this, you could have also done, let's say, rather than passing a thing, you are passing let's say string hello, right? Then again you can see that the behavior will be this primitive thing will be converted to a string object, which means that this will be equivalent to something like new string, and you are passing it like this. Okay, so you can see that both are equivalent. Okay, and yeah, you can try doing something like this, that let's say I am passing something like a number which is like in a string, so that will still not matter, it is going to be a string only, because this JavaScript has no idea that what you are trying to do. Okay, so if you want it to be a number, then you can pass it something like, yeah, you new number, and then inside that you can pass a string also, right? And the number constructor will have that property that if it can understand a valid number from this string, then automatically it will convert it to number, and that's why you can see that this thing is a number, right? So that thing is fine. The idea is that you could use primitives also, but that will be converted to an object. Okay, that is fine. Next, let's see the case in which the function is not directly outside, rather it is a part of some object. So let's say the function is there, but now it is not outside, it is like object dot obj dot foo, that is the function. Now if we call obj dot foo, then we know that whatever is the behavior, the obj dot foo will this will be obj, right? So if we call simply obj dot foo, then the value of this is going to be obj, right? This I am just writing in shortcut, the value of obj will be printed here. But what if now we do the same thing with something like obj.foo.call? If we use that syntax rather than simply calling it, then what will happen? See, uh, if we use obj.foo.call, then definitely we are going to pass some argument, right? Now now what is going to happen, that this thing will now behave as obj.foo is equal to obj.foo.bind null, right? And we know that in that situation, what is the answer, that in that situation the answer is like this is global, right? And that's why this is going to happen. Now let's see that in action also. So const obj is equal to some val 10 is there, and some foo function is there, and that function returns this. Okay, and we are mainly interested in what is the value of this. Okay, so just rather than we can simply print the this here, and that will be sufficient for us. Now obj dot foo, if we simply call it, then what will be printed? We are printing obj, so this obj is printed, right? But if we do something like obj dot call or apply also we can use, it's just that call and apply will be same in this case, because we are not using second argument, we are just using this value in this case. Okay, so now you can see that what is happening, that this is giving us global, right? And that is because it is equivalent to that bind thing which we discussed earlier, that we are binding it with null, and that is because we are using it in non-strict mode, right? If we use it in strict mode, then again the same behavior is that in strict mode, if we are trying to bind with null, then it is going to be this is going to be null, right? What will happen if we don't pass anything? If we don't pass anything, then this is going to be undefined, right? Because if you pass in strict mode, if you pass undefined or nothing, then it is undefined. If you pass null, then only it is null. That is the behavior, right? If you don't use strict mode, right, If you don't use strict mode, then that is going to be global. That is fine. Which means that if we would have used obj.foo.call with no arguments, then this thing will be yeah. So in this case, yeah. So yeah, so I'm saying that if we are in non-strict mode, right, and then we are passing this, then still it is going to be global object, because if we are not in strict mode, then we saw that the behavior is same across all the three things. All the three things means using nothing, that is also global, using undefined, that is also global, and using null, that is also global, in case of non-strict mode. In case of strict mode, this will be in case of null it will be null, and in case of not passing an undefined it will be undefined. Okay, so yeah, so that is fine. Now if we have strict mode, so this is exactly what we discussed earlier, right? If we have strict mode, then this thing will be obviously this will not change, but when we are using something like this, then in strict mode this will be null, and if we are using calling nothing, then it will be undefined, right? Instead of null, if we are not passing anything to call, then it will be undefined. Okay, next see this thing. This is an arrow function. What we know now, since this is an arrow function, then this will be whatever is this like outside. What is outside? Outside, like it is empty object for Node.js, or in browser environment it will be window, right? So that's why obj.foo simply calling, whether you are calling like this or we are calling like this, both cases it will be the default object or window. Why? You see, in this case the reason for default object is that this arrow functions don't have their own this, and that's why it is taking it from the environment, and that's why the answer is the this of the environment. In this case, the reason is that you cannot bind a this, which is an arrow function. You can only bind a this if the function is non-arrow function. Okay, so so just to remember, I will highlight it again after some time, but arrow functions don't have their own this, and arrow function don't have their own arguments. Arguments, if you remember that inside function there is a variable already, there is already a variable available called special variable, which is called arguments. Okay, so normal functions have this variable called arguments. Normal functions have a variable called this, right? But arrow functions don't have this. Means this value will be there, but that will be some different weird things, so you can print it out, but that will not be of our use. And this will be also not for arrow function. This will be taken from the outer context. So yeah, next we'll see that in case of apply, the second argument should be an array. We know that, right? But apart from that, it can also be an array like object. Apart from array, it can also be an array like object. Okay, so which means that if we have some function, let's say foo, and it has abc, let's say, or whatever abc, okay, and if we are trying to see that, yeah, what is abc, and you can return abc whatever, a plus b plus c or whatever, but right now we are just trying to understand that foo dot apply, let's say we are using, and we are not using this, so let's ignore that, but let's say 1 2 3 or let's say 10 20 30. Then when we will execute this code, then we will understand that this is calling the foo function with a, b, c as 10 20 30 respectively, and that's why this is the answer. However, the point which I am making is that this thing args, this thing we discussed that it should be an array, and that's why it is the answer. It turns out that this need not be an array. This can be an array like object also. Now what is the difference between array and array like object? You can see an array like object has a length property and an integer index properties in this range, which means that if we create something like this, let's say const args is equal to an object, right, which has a length property. So let's create a length 3, okay, so 3 length array, right, and then so at 0 index 10 is there, so let's create a 0 index key with value 10. let's create a one index key with value 20, and let's do the same thing for the third index. Okay, sorry, so 0 1 2, the third index will be 2 rather than 3. So you see that this is an array like object. It's not an array, obviously it's an object, but it's an array like object. Why? Because it has a length property like arrays, it has dot length, and this args0, args1 and args2, like in this case even for array args0, args1, args2 is available. Similarly we have also made this available. If we run this, then we will see that the behavior is exactly same, and it will not JavaScript is not giving error that whatever you are passing args, it is not an array, it is not giving an error as long as this thing is valid, right? Now if you don't have an if you don't have a length property or something like this, then you can see that this sort of errors or something will come, right? So but as long as that is a valid array like object, that is not going to give you error. In fact, that is going to give you perfect answer. Okay, so let's say we have to pass, let's say 5 comma 10 for getting the answer 15. Instead of passing an array of two elements 5 comma 10, we can pass an object with length property 2 and 0 as 5 and 1 as 10. That is exactly the same, and it will give us the exact same answer 15. Now what if okay, so let's see one more thing. Let's see one more thing. So let's say that we are not using anything. Is there a way to check arguments? We earlier saw that there is a variable called arguments which is available inside all normal functions, non-arrow functions. It is available, right? Which means that if now you do something like foo 1 2 3, then whatever arguments you have passed, or you could also use something like foo dot call null 1 2 3, or you could also do foo dot apply on 1 2 3. You can understand that all these are equivalent, but the point is that when you are passing 1 to 3 arguments, then you can see that here you are not writing any parameter name. Okay, but even if you're not writing any parameter name, you can get all the arguments passed using this special variable. Like this is a special variable. Similarly, arguments is also a special variable available inside normal functions, which will give you all the list of the arguments. Now turns out that we are talking about array like objects. This arguments also looks like array, but it is not an array. So let's say you print argument 0, argument 1, argument 2, argument 3, you can see, and if you print it, then you will see that you are getting the first argument is 1, second argument is 2, third argument is 3, and the fourth argument is not there, nothing. So it is giving you undefined, right? It looks like an array, but it is not an array. If in fact if you print this arguments, then you will see that you are getting an array like object. It is not an array, but it is an array like object. Okay, so yeah, so I don't know, let's see 0 1 2 3 we saw, right? Let's see the length property. So we see that length property is also there, right? So that is fine, which means that 0 1 2 all the integer indexes are there, and the length property is also there, and that's why even if it is an object, we can say that this is an array like object. Now we know that this is not an array. How do we convert this to an array? Okay, so the thing is that you could use something like this, array.from. So const args is equal to, if I write array.from, and if I pass an array like object, then I can get an actual array from this. So you can see that now args is an actual array. So from array like object, you can convert to array using array.from. So that's what we are discussing here, that if you use array.from and you pass some array like and if you pass some array also, then also it works fine. But so 2 3 4, right? So you see that this is also working. But instead of array, if you are passing array like, then also array.from converts that to a proper array in JavaScript. Next, let's see something like this. So first of all, we know that uh, if we have some, let's say, array, some array, let's say 1 to 3, and we want to let's say copy that array, then you remember, then there was a syntax that you could use something like arr2 is equal to arr dot slice. What it does is that it creates a copy of the array, shallow copy to be precise, but that those details we'll cover later. But actually the base address is different, which means that arr base address and arr2 base address is different. That's why it will return false, but still the values present in them are 1 to 3, 1 to 3. You can see. So basically a copy of the array is created. Okay. Now you remember this, now you see the syntax, how it is working. So actually you see that this passing array is not needed. Why? Because actually this is like, just let me show you. So this was like what? This was like the index, right? So let's say from the first index to the 3 minus 1. Understand? So 3 minus 1, so till the second index. So starting from the first index till the 2 index, it will be sliced, right? And we know that if we don't provide any last index, then automatically it will go till the end, right? And if we don't provide any first index, then it will automatically go till the start from the beginning. And that's why you can see that. So that this is the idea. You don't need to pass anything, but the starting value will be automatically, if you don't pass anything, it will be from the beginning and till the end. So that was this is the trick, that array, whatever array you want to do, you want to execute, you want to copy that dot slice, simply that returns you a copy. Now just tell me one thing, inside this slice, so slice is a function, right? Inside this slice function, what is this? This variable inside this slice function is going to be arr. Why? Because that is how it is being called, right? arr dot slice. It is a method on arr object, right? Arr object, right? Arr object in the sense that array is also an object in that context I'm saying. But this inside slice is arr. What if I used slice from some other array and converted this to this thing? Then this will run like that like the same thing, right? So you can understand that you have to pay attention here. So you can see that this thing is working fine, that is fine, but the idea is that I have to run slice such that inside that this is arr, this variable inside the slice is arr. But there are other ways of doing exactly the same thing. You can do something like this, that instead of arr array, let's say I am using normal array. Okay, I am using normal array, and then I am calling slice. So yeah, so but if I simply call it like this, then directly it will be called. I have to modify it's this variable, right? So rather than directly calling, what if I can do dot call, and now I can pass one argument as the first argument as the this, and what this I want arr as the this. So arr, what this will do, this will call the slice function, but before executing it, it will bind this variable to array arr. which means that now the slice is not running on this array, the slice is actually running on this array. Understand? And that's why if you print this, then you will still get the answer equivalent to the first one, error dot slice, the same answer you are getting. In fact, right now if you do whatever 4 5 78 doesn't matter, actually the answer will be 1 to 3 only, because I have changed the this binding, right? If I have not done this, if I'm directly calling this, then this is 4578, right? But I have changed the this binding now. Now whatever is the this binding, that is the thing on which the slice will be running. And in this case, you know that in case of slice, the this binding should be an array or array like object, right? And that's why this is how it is happening, this is how it is working, right? Now this is what I was saying, that this is you can do something like this also, that empty array dot slice. Why I am doing empty array dot slice? Because I need to get the slice method, right? I know that arrays have slice method, and that's why some array I want, so that slice method is available. If I write some other thing, some object or some 10 dot slice, that will not be available, because slice method is only available on arrays. That's why I am taking any array, on that slice will be available. And now I am changing the this binding, right? So this will work. But as you can clearly see that in this case an additional extra array is created in the memory unnecessarily. We don't use this empty array, but still it is created. Actually, there is another way of cleaner way and more memory efficient way of doing this, is that there is something called prototype, right? And all the so if all the types, so array is a type, right? String is a type, number is a type. So all the types they have their own proper constructors, like we saw that capital number, capital string. Similarly, capital array denotes this array constructor, right? So on that root array type object, array type class, you can say, we have a prototype. And if we use that dot prototype, then after that you can use you can access all the methods directly from there. Okay, but now in this case you are saying that array dot prototype dot slice, which means that I am accessing that slice function, but actually now you cannot directly call it. You cannot directly call it. You can understand? So this here, sorry, yeah. So here you could have done like this also, or you could have done like this also. Both would have worked, right? It's just that the answer will be different, because this is you are running on empty array, right? But you can't do something like array dot prototype dot slice, because it is saying that because this is not because this is not making any sense, right? So let's say ASD is equal to, let's print this ASD. So you can understand that this does not make any sense. When you are calling this, then this internally, like it has to do something, right? And that's why it is returning you empty array. But actually it does not make any sense. Here the empty string is empty array is always created, no matter what. In this case it is not created, because it does not make sense to create it until unless you do something like this. But actually if you do something like this, dot call, right, and then you do something like ARR, then you see that empty array is not created directly the first time this array is created, right? So we are now taking an advantage that instead of creating another array unnecessarily, we are getting rid of that. But anyways, this prototype we have not discussed. This is an advanced topic, so in some advanced course we can dig a bit in this array dot prototype. In fact, you can do pretty interesting things with this, but we'll see that next. Now we have also seen that in if we have an array, right, then we could also create a shallow copy of it using something like spread operator. Yeah, it works, but it only works, and you can clearly see that ARR2 and ARR are different, though both are 1 to 3. This works, but this will not work for array like for all array like objects until unless it is an iterator. So if you create your own array like object, something like this, and then you try to do something like this, then this will fail. This will not work. But arguments is also an array like object, right? But on arguments inside a function for here, let's say if you do the same thing on arguments, then on that array like object it will work. Why that is the case? Because there is something called you have to make you can make something iterable, right? Arguments is actually an iterable, but your this array like object is not iterable by default. Okay, and that's why it is working. How to make something iterable, actually that is a pretty advanced concept, but again we can discuss that in some advanced JavaScript course. The idea is that there is something called symbols, and if an array like object or something has symbol dot iterator property set, then defined, then it will be behaving as an iterable, right? And the point is that if like for example you have created your own custom array like object, then that will be not available by default, but you can create that and make it an iterable. But that is a advanced concept. We'll discuss that later sometime. Okay, so this is fine. Now let's understand this arguments object. We already discussed it, right? That it is a special object available inside functions. It is a local variable available inside a function, and it is an array like object, and in fact it is an iterable also. So that you can use, or in all the iterables you can use triple dot operator, you can use for off operator, sorry, for off operator. So all these things you can use only when this thing is an iterable. So in ARR is an array, so it is an iterable. Inside function you can do that on arguments also. Okay, but these things will not be available on your custom object, custom array like object, until unless you have made that iterable. Okay, so speaking of arguments, what are they are an array like object that we have understood. Now we have also seen that they contain they contain the sort of a list of all the arguments which are passed to that function, and that list is available not as an array but an array like an array like object. That is fine. So let's take an example how it can be useful. So let's say I have a middleware sort of a function called triplet. What it does is that I am calling it with some this, that is fine, it will have some val inside this, but after that I want to call this sum, and I don't know, let's say how many arguments sum has. Some might have 3 arguments, 4 arguments, I don't care, and that many arguments I'm not going to manually take it from here and manually pass it. I just want to be agnostic to that how many arguments are here. Now you can do that by something like this, that uh, if sum dot apply you are using, and then you are passing any null. So null I am just using as a placeholder, because this is anyways not used, but I need to pass arguments as the second argument, and that's why I am using this. Firstly, why this thing is a function, normal function? This triplet cannot be an arrow function. Why? Because arguments will be not available inside arrow functions, right? It is only available in that context, like array like object containing all the arguments, only when it is a non-arrow function, it is a normal function. Okay, so let's see that. Const sum is equal to, let's say, a b, and you are returning a plus b. That is fine. And next you are having a function foo, and that foo function is returning some this dot val, and plus you are calling that function, with the arguments which are passed to triplet. So whatever the arguments are passed to triplet, and the null does not matter there, because null is this is not used there, but I need to pass arguments. Okay, so now if I pass foo dot call, and I pass something, so let's say I pass val 5, and then I pass arguments as let's say I don't know, 1 2 3. Okay, then it will return me some answer, so let's say ASD, and let's print that ASD. Okay, and see what is happening is that I have passed this as val 5, so inside this dot val is 5, that is fine. Now I have passed 3 arguments here, 1 to 3. So arguments, if you print here arguments, then you will get an array like object with 1 to 3, that is fine. And when I'm calling this, then I know that this is only using 2 arguments, so only the first 2 of them will be used. So 1 2 will be used, and this is 5 plus 1 plus 2, that will be 8, and that will be the answer. But now you can understand that this foo is completely agnostic of like how many arguments are here. Like you just pass it from here and it goes there. If you pass 1 2 3, does not matter. If you pass 1 2, that is also fine. If you use 3 here, and if you use some third argument here, and then call it here, so that is fine, that is also fine. And you can see that 8 and 3 11 is the answer in this case, and that and all is working. But this function has nothing to do about number of arguments. So arguments can be useful in situations like this. So if you have a particular this, then 8 plus 2 plus 3, that will be 13, right? Just to highlight the point again, that arrow functions don't have their own arguments variable, arrow functions don't have their own this variable. Okay, so one another use case is that you can use apply to assign a different this object when calling an existing function. This we already saw in that example where we saw this dot slice, right? And we used call or apply. You can use call also, you can use apply also. But the point is that you can use here some custom this, whatever you want, my custom this, and then whatever the arguments. Now it is apply, so you have to pass an array of arguments, whatever. But you can understand that I am calling slice with not this, as rather this. Okay, so that can be the use case. Now let's see that in action. You can do something like this, that obj.foo, yeah. So this function is available on obj. If I call obj.foo, then I will get 25. Why? Because this inside obj.foo will be obj, and obj.val is 5. That's why this dot val will be 5, and 5 into 5 is 25. That is fine. But I could also do something like this. I create another obj2 which does not have this function foo, right? But I can still have val, let's say, right? And I will use this as the new this inside the foo. So I will still call obj.foo, but this function when I'm calling, I don't want obj as this, but I want my this new function as this. So right when I'm calling it, I can call it with, rather than directly calling, I will call it with obj2 as the first argument. Then this attached will be obj2, and now this dot val is 10. Even if this function is running, the attached this dot val is going to be 10 rather than 5, and that's why the answer is going to be 100 in this case. Okay. Another use case is that with apply, the same as the earlier example, rather than simply calling it with another thing. So you can understand here that what we are doing is that we are sort of simulating obj2.foo, even if obj2.foo is not there, but we are sort of simulating that by obj.foo.call obj2. but still we cannot do something like obj.foo directly, because obj2.foo we cannot use directly because obj2.foo is not available here. And if we make it available, then we don't want to rewrite the same logic here again, right? Can it be the way, can there be some way that I can still have obj2.foo, but I don't need to rewrite this whole logic again? And that is where the next use case of apply can be used. So that if you have a function like this, then you can write another function with a different val, that is fine, and with a foo which is same as this. And how to simulate that? I am not writing this logic, this dot val dot a dot b, or you can have hundreds of lines of logic here, whatever. I don't want to write a whole logic. I just want to reuse this same function, and that I can do by writing simply a function. Inside that I am returning the answer of called value of obj.foo, but I am calling it in a specific way. I am calling it as obj.foo.apply this arguments. What this does is that now I am applying, I am calling apply, which means that I am calling it with my custom this, which means that in this case that this is going to be obj2, not obj. And that's why when it will be called, then obj2.foo I will call inside that this function will be called, but still that this will be obj2. That is achieved using this variable, and that's why this should not be an arrow function. This should be a normal function. Secondly, I am passing as the second argument as arguments, which means that whatever I don't care, like I don't need to write any arguments here. Whatever the arguments of obj.foo is there, the same arguments I will pass at obj2.foo, and whatever arguments are there, that is an array like object, that will be transparently passed, right? And when this function will be called, then all the arguments will be automatically assigned, because we know that apply supports array like objects also. Okay, and again these arguments we are using, and that's why again this should not be an arrow function, because this and arguments both are only available in normal function. But you understand that just by using this one line of code, even if this function is like hundreds of lines of code, we are reusing that function rather than writing our own function logic here, right? That can be another use case of apply and arguments for that matter. So you can understand that now we can directly have obj.foo, and we can also have obj2.foo, and it will work as if the same function is available here also, right? And the same thing like obj.foo and in this case obj2 is the this, so my this dot val is 10, and then 2 and 3 are the arguments, so 10 plus 2 plus 3, which is 15, right? But if it is obj.foo, then it is 5 plus 2 plus 3, which is 10. So you can understand that all these functions are directly available on obj2 because we have defined it in such a way, but we are not rewriting the whole logic again. So yeah, that will be all for now for call and apply. In the next video, we are going to have a look at some other topic.